So today's agenda is going to be this. We'll talk about history of DevOps. We'll get to know what is DevOps. We'll get to know why to implement DevOps. There, we will also learn about why not to implement DevOps. What was the difficulty before we implemented DevOps? We'll get to know about various stages of software development lifecycle process, which includes continuous integration, continuous deployment, and continuous delivery. We'll get to know about agility and DevOps. We'll get to know everything about DevOps, starting from the stage when we used to follow the age-old methodology which served IT industry for software developments for decades, till the time it got migrated, till the time the culture changed to DevOps. We'll get to know everything about it. To start, let's see about history of DevOps. So guys, DevOps is nothing but it's a culture. It's a culture which allows different teams to work together, different teams to work seamlessly so that they can perform their software development lifecycle very easily. Wherein, when I talk about software development lifecycle process, it always gives me the idea about a developer who is writing codes of thousands, more than 1,000 lines, and also the team of operations, the guys who maintain those codes, the guys who maintain the application itself. So both teams, development team and operation team, they work together, they work seamlessly together to provide a beautiful flow of software development. So DevOps brings that culture. DevOps encourages to set up open communication between development team and IT operations team that helps in increasing the speed in which applications are delivered, right? So let's understand how this term DevOps is coined. Like any beautiful term which changed the world, which changed the entire culture itself, this term DevOps is coined by one of the independent IT consultant. His name is Patrick DeBus. So this gentleman, he termed this methodology as DevOps, wherein he mixed dev part of developer and ops part of operations together and formed a new term, which is DevOps. This is how the term DevOps evolved, wherein multiple teams started working together and have provided a very beautiful solution, very beautiful methodology wherein the software development happens in today's world. Okay, we'll get to know about what is DevOps. Guys, what basically DevOps is. When we hear about DevOps, what we get to know is DevOps is a never-ending process of continual improvement. It says something about automation, yes. It says things about automation. DevOps brings automation in our infrastructure. It says about implementing best practices with help of multiple tools we use in DevOps to get our work done. We have tools for building our software. We have tools to create a pipeline so that entire thing, all the jobs flow one after another in very orchestrated way. So it helps us in implementing best practices with help of multiple tools which we use in DevOps. Of course, DevOps is a culture. It's a thought process. It's a methodology. It will be very wrong to say that DevOps is a technology in itself. Rather, DevOps is a methodology which brought multiple teams together. DevOps is about implementing agility in information. In total, DevOps brings automation to software development process. Of course, it is the union of people, process, and products, which enables continuous delivery and brings the phase which we initially used to follow of designing, of requirement gathering, of writing the codes, and the tough days of operations team to an end. This is what a DevOps does. Okay, now let's get to know why to implement DevOps. But before we move into why to implement DevOps, I want to give you an idea why not to implement DevOps. What was the drawback? Where the flaws when we did not have DevOps with us? That will be very much important to understand before we know why we implemented DevOps. Guys, let me take you to the days of somewhere around 2006, 2007, when DevOps was not there. That time, the age-old technology, the age-old methodology, age-old model which served IT industry and software development was predominant. The name was, I'm sure that that name is familiar to almost everyone here. The name was waterfall model. As the name says, waterfall, that means something, some fluid which we call as water is falling from somewhere at the top. So let's talk it in this way. Water is falling from cliff. Basically, what happens in waterfall model is, like the way water falls from cliff, it always flows in one direction. At any point of time, if you want to revert back, turn around, and if you want to do some alteration, we cannot do that. It always flows in one direction. Initially, the kind of steps which we used to follow was gathering of requirement, later designing of the requirement which is gathered from clients, implementation on designing part, testing on whatever we have implemented. After that, we used to deploy the entire implemented work. And for sure, maintenance was a part of that. That was a never ending process. Okay, let me just give you an example to move on. Before we move on, think about some big players in market like Amazon. Amazon gives certain requirement to its service provider. Say, for example, Amazon gives the requirement to its service provider that when a user logs in to Amazon, directly user should jump in to a page where he can see the offers which Amazon released for the day. Okay, so this is one of the requirement of Amazon. Now, service provider will write a code so that when a user logs in, he directly goes to the offer page of Amazon rather than going to home page of Amazon. This is a requirement. Now, service provider will select certain set of very good developers who designs it, who sits and design. Fine. What kind of code will be good for it? What syntax we need to follow? Will that be Java? Will that be .NET? Will that be Python or any good high level code which we can follow to have a very good flow of requirement which client is looking for? After that, we'll jump into the implementation part, wherein developer will sit and write code for the design which he prepared. Now, guys, let me tell you, the code, even for a small application or even for a small software, doesn't go less than 200 lines. And even for the larger application or larger software, it even exceeds 1,000 lines. So it goes to that high. Writing that high level code of such a huge number of lines may take 2 to 3 months, even more than that, right? After that, the code goes to testing phase, wherein we have testing team, quality analysis team. They do different kind of testing on top of the code which is written by a developer. That testing could be user acceptance testing, user integrated testing, multiple other kind of testing for which they pull graph and they see what are the bugs which is present there in the code, whether the code meets company standard or not, whether the code is satisfying its standing on client's requirement or not. These kind of tests are done by testing team, quality analysis team, and it is again going to take huge amount of time because testing team is going to do testing not on 10 lines of code or 20 lines of code. They are going to do testing on more than 1,000 lines of code. Debugging is not an easy task, guys. It used to take more than 5 to 6 months for a software or application to develop completely and to get published so that end users can access it. Okay. Now think about the current situation. Now today, if you're opening Facebook and you're opening Facebook tomorrow, there's some change in the homepage of Facebook. Basically, the requirement is changing every day. I'll say every hour also for certain clients. Here at age-old model, which is waterfall model, to meet one certain requirement, it used to take 6 months. How this model can meet the requirement where the client wants some agility, some change in its in its infrastructure every hour, every day. It's not possible. Basically, waterfall model was time consuming. It was very hectic for a developer to write that long code and again a testing team to sit and debug the entire code. Now, if testing team comes up with certain flaws, and when that flaws goes to developer, then the developer is again getting very bad time in fixing it. There were huge drawbacks of waterfall model, which which brought the concept of some new change, some change there in this model. Guys, the change was not directly to DevOps from waterfall model. The change was to something to which we call as Agile methodology. So after waterfall methodology, the world has seen Agile methodology. What happened basically in Agile methodology is now the developer is not writing entire 1,000 line of code at a go. The entire code of 1,000 lines, guys, is now broken into certain iterations. That iteration falls sometime between 2 to 8 weeks. Now, instead of writing 1,000 line of code, a developer is writing say 100 lines of codes. And instead of one single developer writing the entire code, now we have 10 developers who's writing small chunks of code, small iterations of code. That made life of a developer very easy. Now, it's not only developer who is relaxing, but also testing team or quality analysis team also got some relaxation because testing team now they do not need to debug 1,000 lines of code. Rather, they are debugging only 100 lines of code, which was pretty easier, guys. Okay. So now, if a developer is writing 100 lines of code and a testing team member is doing debugging on that 100 lines of code, even though a bug is found, the feedback is immediately sent to the developer and the developer fixes it in no time. So basically the issue of development team and testing team was resolved. Now the software development was happening very fast, but was the deployment was happening fast? Was the end user getting the benefit of developer and quality team? No. Still the deployment was slow. Still, the deployment of code was happening only once the code completed successfully. The entire code was written, entire code was integrated. So there was still a drawback with operations team. Operations team were kept aloof. They were isolated. They do not know what development team and testing team are doing, how they are building, how fast they are building. Operations team are not aware of it. Now guys, let me tell you, if operations team are maintaining infrastructure for 6 to 7 months, it involves huge amount of cost because maintaining infrastructure is not an easy job again because in real time we have more than thousands of servers which needs to be maintained. Maintaining thousands of servers which includes cooling, which includes electricity, lots of costs are involved there. Maintaining that was for such a long period of time without getting exposed to end user was lost to company, was a big trouble for operations team. That needs to be resolved, that has to be addressed as soon as possible. So a new methodology came, a new thought came. That methodology, that thought was DevOps. DevOps brought both development team and operations team together. That is why the name was coined as DevOps. The distances in between development team and operations team was removed. Now they can easily communicate with each other. Now operations team do not need to wait for entire code to be written and to deploy the whole chunk of such a big code. They can deploy small chunks of code. Okay, to give you an example how it works. Now We are logged into Zoom so that we are talking with each other. We are communicating with each other. I'm sharing my screen with each other. I can see some of the participants on my right column. That fine, these are the participants who have joined the session. I can ping someone privately, publicly. I can record these sessions. So these are like different components of one single tool, which we say as Zoom. Do you really think, guys, that when Zoom was developed, it is one single code which is written for all these components? The answer will be big no. We have separate components, we have separate code, separate chunk of code for each component. Maybe initially when the code started, when the code was getting developed, the first code will be for the component if I'm able to connect Zoom with web or not. So somebody who is trying to log in, putting in its credentials in Zoom, whether with that credentials, the Zoom is visible there on web or not. That is my first component. This component is tested. Fine, it's tested successfully. This is one chunk. This chunk is nothing but a single iteration. Certain time period may be allocated for this chunk. Now, once this code completed successfully, we got a positive feedback for this. We started writing code for another chunk, for another iteration. That iteration may be for chat option. Once the chat option completed successfully, the feedback was positive. Both the components, both the iterations were integrated with each other. So now you see, guys, the development, testing, and deployment that is happening parallelly. I'm not waiting for entire code of Zoom to be written. I'm not waiting for entire component of Zoom to be developed and then it is published there in web. I'm testing for each and every component separately, right? So this is how DevOps works. DevOps allows us to test each and every component on real-time basis with real-time end users so that if they give us feedback, I'll try to incorporate the feedback which is given by users in my code. This is how DevOps goes. This is how the entire flow goes. Okay. Now we'll talk about 6 C's there in DevOps. What 6 C's is? Also, while I'm talking about 6 C's, I'll try to integrate all these C with the software development lifecycle methodology, which is nothing but the analyzing part, which is requirement gathering part, planning part, design part, build part, test part, deployment part. I'll try to relate everything so that it will be very clear to all of you. The 6C starts with continuous business planning. Continuous business planning is nothing but, again, let's relate with the basics. Let's stick to the basics. Continuous business planning is nothing but the requirement gathering. Amazon is giving me the requirement that, yes, sir, I want user to log in directly to my offer page, not to my home page. I am getting the requirement that after that I'll get into planning. That is nothing but continuous business planning. Next comes integration. Developers are writing code for separate different modules, separate different components, which Amazon wants to see on its web page. It can be first the payment section. It can be secondly for the user section. It can be a section for mobile accessories separately. It can be separate for electronic accessories separately. So different components are made on the web page of Amazon, and that is integrated together in continual manner. That is called continuous integration. Continuous testing is happening on a very real-time basis. When individual component is met, say the component is met wherein when a user logs in, he or she is able to check the offer which Amazon is releasing today for electronic items. That is tested. The test completed successfully in no time, guys, in no time. Now the testing moved to next set of code which is written by developer. That is nothing but the offer which Amazon releases for some other item. This goes and goes on and goes on till the time entire requirement is met. That is continuous testing. Continuous integration is happening Continuous testing is happening. Fine. Now it moved to continuous deployment. When a certain code is written, testing is done, the code is deployed so that end users can access it. They can get the advantage of offer which Amazon is releasing today for electronic items. They can purchase some beautiful mobiles for themselves. They can purchase some beautiful headphone for themselves at very less price, at the offered price which Amazon is releasing. That they can achieve by using continuous deployment method. And lastly, guys, continuous monitoring. There is certain team initially which used to sit, and the team's job was to monitor thousands of mail which is coming there in that mailbox. It was a big pressure on the exchange server as well as the person who is sitting on front on screen and monitoring those emails, monitoring those alerts. Everything was mitigated, everything was addressed in this DevOps methodology and brought continuous integration, continuous testing, continuous deployment, continuous monitoring together. Sticking to the basics, what we are doing here, we are planning it, we are designing it, we are building it, we are testing it, and lastly, we are deploying it so that end users can use it, can access it. This is called 6 C's of DevOps, by means of which continuous development and continuous deployment or continuous delivery is achieved. What we do basically in order to achieve these 6 C's, we have multiple tools in DevOps. In our session, in our curriculum, I'll take you through all the important tools which is holding big chunk of market, which allows us to get to stay separate from anyone who doesn't know DevOps, who doesn't know those renowned tools in DevOps. I'll take you through those tools in our curriculum, in our these sessions. Okay. It started from 2008, 2009. DevOps started from 2008, 2009. And from there, those engineers or technical individuals who started inheriting this technology, this methodology, always got a rise in their salary, always got a rise in their career growth, career opportunity. And it's increasing very much exponentially since then. It's always a good thought to learn DevOps. And I'm sure in coming years, this is about to go on peak. Let's move on to our next slides. Let's understand each and every topic one by one. What is continuous integration? What are the different tools we use in continuous integration? We'll get to know about this. In DevOps, when I say about continuous integration, this term integration, I'm sure this must be very familiar to you guys. Integration, it says something to integrate. Some tools, some process is going to get integrated with each other. What is that process? How that process can be integrated with each other? That process is nothing but the basic of software development, which is planning, building, testing, deployment, and monitoring. These all processes are getting integrated with each other. The integration happens very much continuously. Okay, so giving you an example again for Zoom. Let's come to Zoom. Let's take an example of Zoom. Say developer A is writing code for chat option, so that chat option can work privately as well as publicly. Another developer B is writing a code for recording the entire session. Another developer is writing a code for sharing a screen. Maybe it can be video, it can be just the screen. Okay, so these three developers are working together on different components. These three components needs to be integrated together so that when it gets published, when it gets released, the end users can take advantage of it. This integration happens in continual manner without any hindrance by using DevOps. Herein, we use different tools for this. The tools which we do have in market is Bamboo, Jenkins, and multiple others. But Jenkins is holding big chunk of market. The most renowned tool which we now use there for integration, for continuous integration in Jenkins. In our curriculum, we'll talk about Jenkins as a tool when we are talking about DevOps. So as the slide says, continuous integration is a development practice that requires developers to integrate code into central repository several times a day so that the continuous integration can be achieved seamlessly. Okay, it stops waiting to find out if your code is going to work or not. Nobody is going to wait in this world, guys. Developer writes a code. What he wants is immediately a feedback should come on his code so that in case if any rectification is needed, he or she can immediately sit and rectify it. That is what continuous integration does, right? It allows multiple tools, multiple teams to get integrated, to work together so that a seamless flow of software development can achieved. Okay, let's move to continuous deployment. Let's understand what continuous deployment is. Herein, we'll understand the entire life cycle of software development by using DevOps as a methodology because deployment comes at the end part. We need to understand the entire stages, all the life cycles which a DevOps methodology follows. It starts with the code getting written for a software development. Now, do you really think that the code sits on a developer's machine? Because how a developer, let me tell you how a developer writes a code. Developer uses his very latest laptop or desktop with very latest configuration and starts writing code in it. The code, when it's written, if it resides on the machine, on the laptop or desktop or developer, there are chances that the laptop can get damaged. And if the laptop gets damaged, the entire code which is written by developer in it is lost. All the effort which developer put to write thousands of lines of code is gone. That is lost, right? So that needs to be rectified. That needs to be mitigated. That needs to be addressed. So a life cycle in DevOps gives us that flow. That life cycle is one version control system, which is also called source code management life cycle. What happens, guys, basically in this life cycle is the entire code is maintained there at certain location, certain central location. That central location could be central repository, could be local repository, right? So we have certain tools for that, which provides us that flexibility to save our effort at some central locations so that even though developer's machine crashes, his effort is safe. His effort is still intact. That is one of the life cycle of DevOps. Next comes continuous testing. That is another life cycle of DevOps. In continuous testing, the code which is kept there at central repository is tested continuously, right? Is tested continuously. If any feedback is required, that feedback is provided to developer so that developer works on it, mitigates and resolves it if needed. Next comes the part of continuous deployment, where the tested code goes to web so that end users can use it. We have separate technologies which is used for that. Here, I'll give you a brief segregation on what VM is and what containerization is. We can deploy the code which is written by developer, the effort which has been put by developer to web in two different methods. It can be deployed either on bare metal servers or it can be deployed on containers. When I talk about bare metal servers, it means that our servers, big boxes which we see in our data centers, those big heavy boxes. Let me tell you guys, I've worked in data centers also, and each of the box weighs tons. So our data initially used to reside in those big heavy boxes. Later on, we moved into the concept of virtual machines. We started creating virtual machines on top of the bare metal boxes. Okay, but when we are creating virtual machines, there were certain constraints, certain restrictions in that. Each of the bare metal box was having certain limit containing performance under consideration, containing cost under consideration, containing space under consideration, that these many VMs only can be created on a bare metal box, right? The technology evolved, and now we have container concept, wherein we can create n number of containers on a bare metal box. We no need to deploy or we no need to install individual OSs on each containers. We can have the bare minimum binaries or libraries which is required for our software to work seamlessly. That brought the concept of container. This is just an overview about VM and container. Once we are going into containerization technologies, which is Docker, I'll give you much more in depth of what VM is, how many types of VM are there. Now we have type 1 and type 2 VMs also in market. What container is, what are the different technologies we follow in container, who are different vendors of containers. I'll give you an overview when we are talking about container as a technology. So for deployment guys, we can either deploy our software on either bare metal server, on top of which we can create VM, or we can deploy it on containers. The advantage of deploying on container is that we can deploy individual components of a software on separate containers. Say, for example, for the Zoom app, I can deploy the component of chat on one container, component of screen sharing on another container, component of recording on another container. And these all containers communicate with each other by using several APIs, several interfaces, right? So API acts like a waiter. What it does is it allows anybody who goes to a restaurant to put his request, to put his order, and carries that order to chef. So that chef prepares it and brings the prepared item in front of customer to restaurant. So API works in that way. It allows different components which is sitting in different containers to communicate with each other. Okay, so that concept comes when we talk about container. So the benefit there is, even though if my one component goes down, still my other component is working. For example, again coming back to Zoom app, even though my chat option gets some bug, still the option of screen sharing is on. Still the option of voice recording or screen recording is on. That is the advantage of having our application deployed on several containers rather than it gets deployed on one single VM. If we deploy it on one single VM, if the VM crashes, entire app settles down, entire app goes down. That is what brought the concept or need of a separate technology to which we call as container. Other methods which we follow to deploy our code is to have the need of infrastructure as a code, wherein initially how we used to do is, I know, Morish, you are a Linux administrator. What we do here is we write several lines of code there in Perl or shell in shebang format, wherein we put that script, we put that code, and this code works in a very chronicle way. This works like cron jobs, one after another on a set time manner, right? But writing this Perl or shell is not an easy job. This involves the knowledge of lots of scripting, lots of variables, and it is also not platform independent, right? So initially the concept which we used to follow, which was infrastructure as a code, that had drawbacks because it was getting written it was written in some complex scripts, which can be Perl, shell, by using shebang methodology, right? That has to overcome. That brought us to the need of some configuration management tools, much easy to use, much easy to understand, much easy to handle, much easy to debug. Some of the tools which you do have in market is Ansible, Puppet, Chef, SaltStack, and couple of others are also there. We'll get to know all about these tools when we get into those components. This configuration management tool helped us to deploy our code, our effort in very easy manner to web, to end users, so that end users can access it, so that end users can use it. Last comes the monitoring phase of the software development lifecycle, wherein the entire thing is monitored. So what we saw in software development lifecycle or the different phases of DevOps, we saw a version control system, we saw a continuous testing concepts, we saw the concept of continuous deployment, where we use either container or VM or configuration management tools. We saw the concept of monitoring. These all is integrated by using continuous integration concepts, and this by means of these life cycles, our software, whatever it's written, gets deployed so that end users can use it. Okay. So we spoke about different stages of DevOps lifecycle. We spoke about version control system. We spoke about continuous integration. We spoke about continuous delivery. We spoke about continuous deployment, and the concept which integrates, which keeps all these stages intact is continuous monitoring. For every stage, we get a feedback. If there's some flaw during continuous integration, we get a feedback. A feedback generates, and that feedback goes to respective teams. It can be developer, it can be testing team, it can be project manager. Nowadays, I mean, I won't say nowadays, we used to follow this a year back maybe. There was the concept of Scrum Master. The Scrum Master used to handle everything. We used to create sprints, and a Scrum Master used to sit, and the Scrum Master used to drive everything. Now the things have changed. We have some different methodologies also for that. Okay, so this is how, guys, the DevOps life cycle goes. These all are the different stages in DevOps life cycle. Let's move on to another slide. Okay, so we spoke about continuous deployment. What it does, it maintains development and test environment to better match production. That's for sure. It allows development and testing work together so that whatever release which it produces, that is the best release which developer can put in. Maintain a staging environment that emulates production. That is also very much true. Okay, we have a couple of other points also in this. It allows us to get automated deployment, decouples deployment for release very easily, so that individual iterations can be released and can get released to web so that end users can access it, right? So this is what we can achieve by using continuous deployment. Let's move on to another slide. Continuous delivery. This is nothing but putting all our efforts onto web so that we can access it, right? Now, let's move into some other components, which is how it flows, how it goes, what is source repository, what are the different steps, which is build, test, release, how it happens, what are the different kinds of these stages. Let's start with source repository. What source repository is? As I already said, source repository is nothing but it is something which manages the changes to code. It can be computer programs, it can be the code for large websites or any other collection of information. It stores everything in it. It doesn't only store it, it also allows different team members of development team to work together. Say I'm sitting in India, somebody sitting in Chicago, somebody sits at some other geographical location, right? So we all can communicate with each other. Say somebody who's sitting in Chicago is also developer, my teammate. I sit in India, I also have to write some code. I write some code, I put that code at central repository. That central repository goes to web, goes to cloud. Somebody who is sitting in Chicago wants to see what Sumit wrote, they can easily go and see there. They can easily go and check in there, right? That repository is called repository, which allows different team members sitting at multiple geographical locations to communicate with each other. So it not only provides redundancy to our code, it not only saves our code from any kind of fault, it also allows different team members to work with each other, to integrate with each other, right? Now we have different kinds of source code repository. Some are centralized, some are decentralized. In centralized, the developer who is sitting with his machine is directly posting all his code, all his effort to central code. There is only one single layer of redundancy here. For some reason, if his machine fails, then there is only central repository where the code sits. For some reason, if the server fails, the server which is maintaining the central repository, the code is gone. The code is not accessible. This flaw, this drawback, this problem has been taken care by decentralized version control system. In decentralized version control system, we have multiple copies of our code, of our effort. One is called the working copy, which goes to local repository. Basically, in distributed version control system or decentralized version control system, we maintain two copies of our effort, two copies of our information. One is called the working copy, wherein the working copy sits at a location where I am writing something, still I am doing something, still I am changing something. It sits there. When I'm satisfied with the change which I made, I push it at a local repository. When I am all set that this local repository is good, and even though I publish it on my web, somebody who's sitting on some other geographical location will not get panicked by seeing the code which I wrote. I'll be pushing that code to central repository. So I'm maintaining two different level of redundancies on my effort, on my information. So it's a kind of two layer of redundancy to any of the effort which I put in. This is what we'll discuss further when we'll speak about source repository or version control system. Next comes the CI server. CI server is nothing but we say as continuous integration server. There we have the concept of build, test, result. Here's what build is. Is it actually building our code? What actually it is doing? If build is building the code, then what test and what result section of the CI is doing? Is it doing some different tasks? Let's understand that base. What build is doing? Let me give you just a brief idea. Any of the code which is written by developer, the code is written in either Java, it is written in either Python or .NET or C or C++ or any other language. This code needs to be converted into a machine understandable language, the language which computer can understand. How we can convert that? We can convert that by compiling the code which is written by developer. That compilation is carried under build phase. So in build phase, what build does is build compiles the code so that the code which is written by developer now can be understood by the machine also. It converts the raw format of the code into machine understandable format. Next, the code which is written goes to testing, and then the result is published in packaged format. The packaged could be jar format, which is JAR. It could be WAR format, which is WAR. It could be EAR format, which is enterprise archived. Okay. So in these three formats, my result, my code, my source code can be packaged, which is further deployed to anywhere we want to do, we want to deploy. It can be deployed on a bare metal server. It can be deployed on a container where we wish to deploy. This is what we do in continuous integration stage. We build it, we test it, and the result is then packaged into the jar format, WAR format, or EAR format so that it can be further deployed. It can be further put on any place, any location which we want to do, which we want to achieve. Next, it comes as deployment. Again, as we have already seen in our previous slides, that for deployment, we can use either VM or we can use container. We have seen the differences in between VM and container. We'll see it further when we are moving into container as a topic, containerization as a topic there in our curriculum. Another methodology which it can follow is by using infrastructure as a code, but that is a legacy one. The script is very complex. It is platform dependent. If I'm writing a code on any of the Linux distribution, it won't work on any of the Mac distribution. It won't work on any of the Windows distribution. So that is like platform dependent. We need to have some transition there. We need to have some agility, some change there. That agility is brought by using configuration management tool, which is now available tools. The most renowned tools in market are Ansible, Puppet, Chef, and SaltStack. We'll get to know about these. We'll get to know about architecture. We'll get to know about push and pull-based architecture when we are going through the configuration management and deployment technologies, continuous deployment technologies. Okay, so this slide shows about agility in DevOps, the Agile model in DevOps. It tells us how things have changed from very initial model to such a latest model where even though if we are doing anything wrong, even though if we are lagging anywhere, we do not need to waste our time. We do not need to wait for months and months to go to, to get the feedback. It allows us to get the feedback in no time, within a moment. And a developer who is working on it can fix it very soon, very easily. There are certain principles which agile development process follows. I'll be sharing these slides post this session. You can go through these principles. These principles will help you understand what the failure could be, how the failure can be mitigated, how the failure can be addressed. What is Scrum? What is Scrum Master? You'll get to know when you are going through these slides and getting known to these 12 principles of Agile. Okay, so now coming to the last section, this we have already seen in our previous discussions where we spoke about Agile methodology. We review, test, build, design, and plan, and that happens in very cyclic manner in various sprints or various iterations. The iterations could be for 2 to 8 weeks. That is carried over, that is driven by Scrum Master, which now we call as Product Manager also. And once everything is satisfied, once it meets all the criteria, it is then pushed so that it gets published to web and all end users can see it, all end users can access it. I would like to finish today's session with the topic of continuous monitoring. Guys, it's not over if the software is developed and it gets published. There should be a mechanism which monitors all ups and downs which comes in a software, in an application. We use multiple applications in our mobile. Sometimes our application hangs. Sometimes we are not able to open our application. Sometimes when we open our application, we get some error messages, right? It happens to everyone. There should be some mechanism which reports that yes, this application, this component of my software is facing some issues. And that mechanism should carry the feedback to respective teams. For a software development, it carries the feedback to a developer, to a testing team, to a product manager, so that it could be addressed on timely basis, on timely manner. A proper monitoring mechanism is important. When we are talking about monitoring, we'll get to know about certain well-known monitoring tools in market, which is Nagios or Splunk, wherein we can define all the servers which is participating in software release. Now, in infrastructure, in nowadays, the growing infrastructure will have more than 1,000 servers, right? All the servers, each and every of the servers, monitoring is not an easy task. If I put even 10 operations engineer Monitoring thousands of servers is not an easy job for them. It's very hectic. It's not only the monitoring, it also includes upgrading the packages, right? To which in Windows term we call as patch upgrades. So patch upgrades of 1,000 Windows server is not an easy job. There should be some mechanism which monitors that my patch is age old. It needs some upgrade and it provides the feedback to respective teams. We'll understand the monitoring mechanism by using certain tools, which is well defined in market. Now, therein we'll see how to define all the servers, how to make a server controlling machine and another server's controller machine, so that if a patch upgrade is needed, one individual no need to go and individually set and upgrade each of the server, each of the box. It can be upgraded automatically by using certain technology, certain methodology. We'll see that. We will also see by means of monitoring that with the increasing requirement, with the increasing package, with the increasing installation of different softwares, is it impacting the performance of my server? Now, say 1,000 users are logging in on daily basis to Amazon website. Say if tomorrow 2,000 users logs in, will that impact my performance? And if it impact my performance, what is the CPU utilization of my server so that it can handle the traffic? Everything needs to be monitored. If the CPU utilization goes high, what is the current utilization? Can it handle the next moment upgrade of traffic? Can it handle the next moment inflow of traffic? Everything needs to be monitored. We need to set up a proper mechanism for that. We'll understand that mechanism when we are understanding monitoring as a topic. So guys, this is what about the entire DevOps life cycle. It starts from very initial, which is design phase. It goes through multiple integration process, which allows us to build, to test, to review, and to monitor. It ends with monitoring, where we monitor everything, whatever happens in our software development. Whenever a software gets released, this brings different team, as I already said, different teams, which is in this case monitoring team, who monitors the performance, who monitors the patch upgrades, who monitors any software upgrades on servers, team who maintains the database, team who maintains the storages for many of the user inputs, many of the user feedbacks, many of the user datas, user credentials in it. Also, it maintains the code which is written for development by developers together. So this all cycle is well maintained in different stages of DevOps life cycle. We'll get to know more about these life cycles when we are going through individual sections of our course. Thank you everyone for joining in. Okay, thank you. Thank you everyone for joining in.
Janbass Training. Learn and grow.